Picture this. You lock your phone. You send a private message. You log into your bank. All of that safety is built on one assumption. Some problems take normal computers an absurd amount of time to solve. Now imagine a new kind of computer that doesn't just run faster. It plays a different game. A machine that could crack certain impossible problems so quickly it would feel like cheating. That's quantum computing. And if it scales the way scientists hope, it won't just upgrade technology, it will rewrite what's possible. In the next few minutes, I'll explain quantum computing without the brain melt. No equations, no jargon, just the core idea, what it can do, what it can't, and why it matters to your life. If this kind of simple, no jargon tech explained is your thing, hit like so YouTube knows to show you more of it. And subscribe, because I'm making a whole series like this. Right now, computers run the modern world. Maps, shipping, medicine, finance, AI, the entire internet. But there are problems that explode in complexity. Add a few more variables, and the number of possibilities goes from big to laughably huge. It's like trying to open a combination lock. But the lock has a billion dials. Classical computers are incredible. But for certain puzzles, they hit a wall. Quantum computing is our attempt to go around that wall. Normal computers use bits. A bit is either 0 or 1, like a light switch, off or on. Quantum computers use qubits. And a qubit is not stuck. It can behave like 0 and 1 at the same time, in a special way, until you measure it. If that sounds confusing, here's the human version. A classical computer explores options mostly one path at a time. A quantum computer can explore many possibilities in parallel, then collapse to an answer when you check it. That many possibilities at once is called superposition. Imagine you're looking for your lost key in a hotel with 200 rooms. A classical computer is like checking rooms one by one. Room 1, no. Room 2, no. Room 3. A quantum computer is like having a weird probability cloud version of you, checking lots of rooms at once. Not magic, just different physics. And when you finally open the door and look, the situation snaps into one outcome. That's the vibe. Now, the second trick is where it gets spooky. Qubits can become entangled, meaning two qubits become linked so the state of one is connected to the other. Einstein hated this and called it spooky action at a distance, because it feels like the universe is coordinating things behind the scenes. For computing, entanglement is powerful because it lets qubits work together as one system. It's like teamwork, where the teammates share a brain. Quick reality check. Quantum computers are not better computers for everything. They won't replace your laptop. They won't make YouTube load faster. They won't give you more FPS in games. Think of them like a specialized tool. A chainsaw isn't better than a knife at everything. But if your job is cutting down trees, the knife is irrelevant. Quantum computers are like that for certain categories of problems. So, what problems? Medicine. Faster drug discovery. Here's the big issue. Molecules are quantum systems. To predict how a molecule behaves, classical computers have to approximate, simplify, and guess a lot. Quantum computers could model molecules more naturally. That could speed up finding promising drug candidates, reduce trial and error, and help us design treatments more efficiently. Not instant cures tomorrow. More like the research pipeline gets dramatically smarter. New materials. Better batteries, cleaner energy. Want batteries that store more energy, charge faster, and last longer. Want better solar materials? Want new catalysts that make industrial processes cleaner? Materials science is basically find the best atomic arrangement for this job. But the number of possible arrangements is enormous. Quantum computing could help search that space. Even small improvements here can reshape industries. Optimization, making the world less wasteful. This one is sneaky, but huge. The world is full of optimization problems. Delivery routes, airline schedules, factory planning, supply chains, investment balancing. A tiny improvement, like 1% or 2%, can mean billions saved and less fuel burned. Quantum approaches may help solve certain optimization problems more efficiently. That's not flashy, but it's world-changing. Cybersecurity. Here's the scary one. A lot of modern encryption relies on math problems that are easy one way and extremely hard the other way. Classical computers would take an impractical amount of time to break them, but a sufficiently powerful quantum computer could break some widely used encryption methods. That's why you hear about post-quantum cryptography, new encryption designed to survive in a quantum world. So quantum computing isn't just a new tool. It's also a reason we're redesigning digital security. Let's kill a few myths. Myth 1. Quantum computers will replace normal computers. Truth? No. Most tasks don't benefit. Classical computers stay dominant for everyday stuff. Myth 2. Quantum computers can do anything instantly. Truth? They're powerful for specific problem types, not everything. Myth 3. Quantum computing is basically magic. Truth, it's real physics, but extremely fragile. Quantum systems hate the real world. Heat, vibration, and tiny disturbances can wreck a calculation. That's why many quantum machines run insanely cold and need heavy shielding. Also, errors. Right now, you often need many physical qubits to create one stable, reliable, logical qubit. So the race isn't just make it faster, it's make it stable, make it scalable, make it reliable. We're early. Think computers in the 1940s, early, massive, limited, expensive, but pointing to something big. So here's the simplified summary. Bits are 0 or 1. Qubits can represent multiple possibilities. Entanglement lets them act like a connected system. Quantum computers won't replace normal computers, but for certain problems, they could be a breakthrough. And that could reshape medicine, energy, logistics, and cybersecurity. Remember the idea from the start. A computer that feels like it's cheating. That's the promise. But the real question is, what happens when a tool this powerful becomes practical? Do we use it first for medicine and clean energy, or for surveillance and breaking security? Because quantum computing isn't just a technology upgrade, it's a new kind of power. And if you want part 2, tap subscribe so you don't miss it. And drop a like if this made quantum computing finally click.